Hi everyone, and welcome back. We have Sven from GFrog today with us. Thank you, Sven, for joining us today. I hope you will enjoy the rest of the conference. I want to remember everyone that you can ask questions on YouTube channel or on the Slack channel for this track. And that's all. Sven, if you can please introduce yourself and proceed with the presentation. Thank you very
Oh,
much.
hello here, right out of Germany. And finally, we have something that's called good weather. So you have definitely better weather than we, but finally, we have no rain anymore. And this is really, really good. So that's the first thing, but we want to talk today a little bit about Polyglot security holes and why it's time to fight back and how to fight back. And we want to talk a little bit what's the tooling you could use and what are the pros and cons and so on. If you have any questions, please do it. I'm not sure if I can get these questions during the talk. If I will see it here in the chat during the talk, I will try to give you an answer quite soonish. Otherwise, I think we have some kind of Q&A in the end. So feel free to ask. Otherwise, I would really appreciate if you are following my social media channels, Twitter, YouTube, and so on. But back to the topic. So I think you see my screen. You can hear me well, I hope so. Otherwise, let the people know so that they can tune the technique. And we want to start talking about polyglot security hole. So what's a polyglot security hole? Huh? Oh, by the way, my name is Sven Ruppert. I'm from Germany. I'm developer advocate at JFrog. And mostly in Germany, I'm known as the man in the woods because since the pandemic, I'm not traveling to conferences. I'm going to the forest, recording there my talks and doing all this stuff and pushing this one to YouTube. So if you want to see outdoor style IT related cybersecurity videos, check out my YouTube channel. I would really appreciate to see you as my new subscriber. I have them in German, I have them in English. So make sure that if you want to have them in English, try out the Auto Nerd, not the Sven Ruppert, because there's a German channel. Okay, so far, I have an excuse that I'm using here to explain the polyglot environment that's called cloud native. Don't worry, everything what I'm explaining here is suitable for cloud native, for serverless, for monolith, whatever. But Cloud Native will show a few things that I really want to highlight, and they're using good words for it. It's established in the structure and culture, and this is why I'm using Cloud Native here. Don't worry, I don't want to go into all details of this Cloud Native world. We have definitely not enough time for this one. I will just highlight a few topics so that we can use this one to compare a few things or to have this as an argumentation structure. And well, let's start. So the cloud native or this based on services or this splitting up monolith world is more or less that they are talking about service oriented architectures. Means long time ago we had this with core bar XML RPC and what other technologies, RMI. We had this approach of splitting of things in several things so that we have distributed systems since a long time. But now with the technology move, with acceleration on the hardware and all this stuff, we are finally able to do a lot more that in the practical world, what we know since a long time in theoretical world, but it was too difficult. So we can split up all this stuff. We have good networks and we can start sharing now these use cases over different nodes and making sure that they are working properly. Why I'm talking about this? Because if you're looking at this, how to split up this to microservices means that a human has to decide what is a good bunch of use cases that are fitting together and they are suitable for one microservice. On the other side, we have this API-oriented communication. So a bunch of services are start communicating to each other, and then the technology can help a little bit more. So here it will be from more use case or human-oriented tasks to do to more technical tasks. So If you're talking about an API-oriented communication, we have now technologies that will start a communication. We can map it with toolings and also, so the tooling will be more and more powerful on this level. And even if you're going down to container-based infrastructure, so we have now the virtualization, we have now the possibility to play around with a bunch of technologies on a single laptop in a way we hadn't long time ago. I mean, 10 or 15 years ago. But the cloud native area is not only discussing the DevOps world or the whole definition of what step is done in what order and who's responsible for what, but they are talking explicitly about DevSecOps. So what is the difference between this security topics to the pure DevOps thing? But before we are covering this one, I want to highlight a little bit why we are doing this split up. We want to split up all this because we want to have shorter release cycles. Instead of deploying every few months, we are deploying a few times per day now. And this means you need tiny pieces. You can provision them very fast. You can have an overseeable amount of technology that you're tweaking and changing so that you can go in your releases forward and backward. We at JFrog, we are going a step further and saying there is no version anymore. We are talking about fluid or liquid software because there is just the actual state of the software, and then you have to go forward and backward if there are any changes. Why we're doing it? Because we have some stuff that is required by the customer, the feedback loop, or there's a technical need, or there's a vulnerability. And we have to change the system quite fast. And then if you have all these tiny pieces, it's perfect. This leads to some behavior. For example, if you have a bunch of tiny pieces that are composed to a whole use case of the whole application instead of one monolith, what we can do is we can decide to rewrite a microservice instead of maintaining, instead of refactoring this one. And this is a trend I'm seeing in the industry, that instead of maintaining software, they're just throwing it away and start writing it from scratch because it's just a tiny one. It's a microservice. It's something, or a function if you're going serverless. So this is okay. But on the other side, with the virtualization technology in the background, start playing around with different technologies. And this leads to polyglot environments. If you're looking at the service mesh or a bunch of microservices, every microservice can be in a different technology. For me personally, I'm coding Java since 1996. I worked a long time in this, but I never wrote something in, let's say, in Go. I'm not an expert in Go. I have no clue about Go. So if I'm now start writing a microservice in Go, I'm a junior. I'm a junior again. Maybe I'm learning faster than a really junior that just started coding a few years ago, but I'm doing all these mistakes. I have to learn the whole ecosystem, how the compiler behaves, what are the tooling, how to debug, what is a good code style, what are the good patterns, the bad patterns for this technology, and so on and so on. So, yeah, it's nice if you can get rid very fast of a microservice with a traditional technology and you want to try something out, you're learning a lot, but have in mind that this polyglot environment, this bunch of different microservices, maybe in different technologies, will lead to some stuff that is not so trivial. And this means that you have now a multidimensional, a really, really multidimensional environment talking about attack vectors against your system, if you are talking about vulnerabilities here. Okay, so this is more or less the first thing. I want to cut out now all these different microservices. Now I want just to focus on one single thing. It could be a monolith, it could be a microservice. I don't care about this one. But at this point, if you're looking at this tech stack, most people start thinking, okay, now it's not polyglot anymore. So now it's one tech stack. It's one thing I'm using. So far, it's okay. But we have to think about that. We have this application layer. This is where we are writing our code. So I'm writing Java, I'm writing in Go, I'm whatever. And then I'm wrapping it inside, or it must run on top of an operating system. For example, Linux. I'm a Linux expert, yes or no? Mostly, I'm confident with some kind of operating system, but all these different distributions, or maybe it's an Alpine, it's an Debian, it's an whatever, they are slightly different. But okay, I'm able to deal with Linux, so I'm confident with this one. And then it will run in Docker because you want to start virtualizing this stuff, and so on and so on. And then it's going into this containerized Kubernetes universe, and then you have a bunch of lifecycle things that are going on. The most people, what they are forgetting at this point is that you have this DevOps or DevSecOps part that's along the, it's along the whole production steps. It's something that is dealing with every single layers in some way. And if we are talking about this one, then you could see that if you're adding a vulnerability inside your application layer already, it will be existing actively or inactively in all other layers. So it means all vulnerabilities or compliance issues you are adding in some layer will be existing active or inactively, direct or indirectly in all other layers as well. So we should have a view on these different technologies, because you can combine vulnerabilities to different attack vectors. We will cover this one later. But over all this, we have two dimensions I want to highlight. You have one dimension that is more or less domain specific. So this is for the human. A human must decide this makes sense to, I implemented this governmental rule right. There is no mathematical thing that you can validate. It's just, there's a tax law and you have to do it like this. So this is something the machine can't really help with this one. On the other side, we have pure technical things over all layers and inside our DevOps or DevSecOps part that is highly optimized, or it's so technical that the machine can do a wonderful job to help you with everything, with performance, with security, with quality, and so on. So you have to have in mind what part is more a human-based one, what is more a technical one, so domain-specific or technical one. And then you see that what is a place of a vulnerability can have different aspects. Could be a pure technical vulnerability. It could be a vulnerability or a security risk that's on the domain-specific thing. Oh, I can add something that will lead to some costs or whatever. So we are talking here about technical things. So it means a technical part of vulnerabilities. We are not talking about how to make your software fighting against misleaded calculation rules or whatever. Okay, but in the end of all tech layers, we have, with every new tech layer we're adding, we have just more vulnerabilities per definition, because with every tech layer, we are adding more stuff. So, and we have here already some kind of polyglot systems because we're dealing with different technologies. There's one term that's called shift left, and I was able to remember this one if I'm rotating this picture by 90 degrees and saying, okay, shift left means that I'm not fighting against vulnerabilities inside the operation. I'm not fighting against this during the CI environment. Maybe I'm fighting against known vulnerabilities or compliance issues or whatever, even during my coding time, or even more left during the concept phase. What I'm excluding here explicitly is a whole concept phase, because security by design, you have best practices, but you have not this strong tooling that will divide things that are secure. But if you start coding, we have a huge amount of tools that start helping you with all this stuff. So shift left for me starts in this talk at the part or at the time if you start coding. We have now in one microservice all these different tech layers. Then we have to think about, okay, what is corresponding or what I'm seeing here. So what can I see? So if I'm a Java developer, then I know, okay, I'm managing, for example, my dependencies with Maven. So I have my Maven, I have my definition, I'm adding my dependencies, I'm defining my life cycle and all this stuff. And then I have some corresponding repositories, because if I start coding or using technology, I'm not doing everything from scratch by myself. I'm using something that's already existing. And this means I'm grabbing something from outside. So I have a corresponding, for example, Maven repository with some specific behaviors. And then if I'm going to the next layer, I have a different kind of repository. I have Debian repositories, for example, or later then Docker repositories, Helm charts, and so on. The most people forgetting one thing, and this is a whole tech layer you're using for the coding part itself. It means your whole DevOps tool chain or the whole DevOps tooling itself should be treated like a dependency, like a binary you're using. It's an external provided created thing that you will get, and you're using it. So it must be immediately part of the security chain we are talking a little bit later, because this is, for example, one thing that happened with the SolarWinds app. I don't know if you know all the details about the SolarWinds hack. I don't want to go into all details of the SolarWinds hack, but what happened, just a few briefly spelled words here, is that SolarWinds itself, it's a US company. They have 300,000 customers. Okay, it's great for them. And then they got attacked. This hacker group was a really good one because they went before to FireEye. It's a cybersecurity company that helps to protect against cybersecurity attacks. And they had the tool stack, and this was just stolen. With this one, this hacker group broke into this SolarWinds and infrastructure. And what happened? They not compromised the system so that it's unusable. They not used ransomware. They not stole data. All of this stuff they haven't done. They went to the CI pipeline. And in the CI pipeline, what they have done is they tweaked the build or the build chain in a way that with every update they are creating, or with every release they are creating, their own binary was compromised by some external provided binaries by them. And so every fresh created binary out of this pipeline was just a compromised binary. And this one was via automatic updates spread to potential 300,000 customers. And this is amazing. Just think about 300,000 potential targets that will be delivered completely automatically. And this happened. So they infected in a very short amount of time up to, I think, 20,000 customers. And even this is a huge potential. US governments, pharmaceutical industry, automotive, mechanical engineering, whatever. So everything was infected because this management software that SolarWinds is creating is something to manage network infrastructure. So if you have a tool that's managing network infrastructure, you have a few points to think about. First of all, to manage this infrastructure, you need something like administrative rights. So you need some high rights to change something in your infrastructure. And the other thing is, you are at this very critical point inside the company, because here you have all communication structures in your hands with this network infrastructure. And this was exactly what they wanted to have. They wanted to have a multiplicator to a bunch of companies to get in this very, very critical infrastructure part, this communication infrastructure part, networking. And this happened. So what happened after the update? So this was just pushed out to the customers, and the software slept, I think, 1 or 2 weeks. And then it started exploring a little bit the local network and started downloading additional compromised binaries. And this is a really, really bad thing, because even if you're closing the first door of the SolarWinds hack, you don't know how many open windows you have, because every attack was slightly different. Back to the point means here, what we learned from the SolarWinds hack is not even your own tech stack you're running in production must be secured. Your whole production pipeline must be secured. And there, definitely, we are in a polyglot environment because we have so many different technologies. We have so many different tech stacks. And just as a quick question, do you ever scan your Jenkins against known vulnerabilities? So the most people say no to me. And yeah, so it's a new way. It's a new quality of attack vector. They are not searching for final targets. They are searching for multipliers. They are going against the supply chain. So you as a software developer, you are now on two sides. First of all, you don't want to be this guy that is grabbing some compromised binaries. And on the other side, you don't want to be this one that is pushing compromised binaries out to your customers, because both sides are definitely bad for your business. So what you need is you need something that is able to understand what is going on in your whole tech stack. You need to know something that's able to handle everything and all this metadata, and then to scan and to give you the full impact graph. Because if you're focusing just on one technology, this is better than nothing. But if you have different things, so different technologies or different tools that are scanning different tech layers, it's very hard for you to build the full impact graph. Okay. If you have now this whole application stack, and everybody will agree, yeah, this is some kind of polyglot. I want to show you just a short example, really just as an example, that maybe inside your application, even if you don't know it, you have a polyglot system with different life cycles. An example of what I'm using here is based on the Vardin framework. Vardin is a framework that will give you to web components a Java corresponding Java site. So it's open source. You can have it for free. I can recommend it if you're a Java person and you want to write web applications, server-side web applications, and you want to have it quite easy, then this is definitely a choice. Give it a try. But on the other side, what's happening inside? So why I'm choosing this one as an example. So the web components itself, they're standard HTML5, CSS, JavaScript. And maybe some Java developers would say, oh, JavaScript and all this, oh, and NPM, I don't know. It's the next technology. And I'm a server-side developer. I don't want to, but you have to create an UI. Okay, so what are you doing? So what this tool is, for example, giving you is just, they have this fully automated communication structure. And then they have a Java corresponding component. So if you have a button on the website, you will have a new button on the Java side. Perfect. And then even you have test components. So JUnit 5 components that you can use to test exactly this Java written new button. So what's going on? So for example, you have now a component library, you want to map it by yourself, and you start playing around with this technology, and you will find out, okay, I can do this maybe by myself. I'm looking at this one and try to give some service. So one in your team is playing around with NPM and likes it, and he wants to provide a convenient solution for his colleagues so that they don't have to deal with NPM. So just an example. What you would need is the web component you want to map. Web component is standard, so communication, properties, and all this stuff is well defined. Then you need this kind of communication between web component and server side, and then you have this pure Java side. And what you want to provide, for example, is a Java component with a version so that you can push it to your colleagues and they can just stay inside their IDE and code their stuff. But it's providing exactly this one. This is why I'm choosing this example, because you're not writing this communication layer by yourself and all this stuff. But if you're looking in this API, mapping from external components quite easy. So you're not stuck on this Vardin components. You can use SAP UI5 components or whatever. Just must be a pure web component. And if you want to have this one, digging a little bit in the API, by the way, the whole mapping, what you should do, how to implement and all this stuff, I have a dedicated talk on YouTube about web components for Java developers and TDD for Java developers. So you can check out there the full thing. It's a little bit longer video to express how you can code it, test it, and all this stuff. But I want to just highlight a few things. For example, if you want to map this one, you will find out you have these three annotations and you see, oh yeah, copy paste. I have now instead npm install. I can now use an annotation npm package, and then I'm just copy pasting this coordinates and say, okay, and add a version. Okay, now it's fine. I don't have to deal with npm here. Then if you want to import it at some page, so for example, you want to use this, something like an import statement on the HTML5 side, you have something like an annotation again, this JS module, and then you're addressing exactly, I have a badge, I have a button, I have a checkbox, whatever. Okay, easy mapping, you're copy and pasting this stuff. Then you need the definition of a tag. Okay, they wrote UI5 minus badge is a tag, and you have to declare it on the Java side. It's fine. So you have three tags, you're reading a little bit in the documentation, you think, okay, everything is fine. Now I can start combining this one. And in the end, what you will get, you have to map it in a class and so on. It's not part of this talk here today, but in the end, if you're doing all this one, you have a map between two technologies, between NPM and the Java world, the Maven world. And the colleagues that are working with this will see something like, hey, cool, I have a package, I have a dependency, a Maven dependency, and I can just use my UI5 badge like a regular Java class. So you would see on this side, new UI5 badge, you have attributes, you can say set tags, color scheme, and so on, and you can add it to your component graph. And you will see something on, wow, fantastic. But what you're losing at this point. So your colleagues, they see this Java code. They will treat it like Java code. They will do all the best practices like you have done in Java code. But in the background, you have NPM and the whole NPM tech stack and the whole NPM lifecycle. And this is definitely different. So should you do some mapping technologies, or should you hide technologies to have a higher convenience? I would say yes, we need it, because we need to improve our speed. We don't need to reinvent everything. So we should use existing things, and then we start integrating these technologies. So talking about open source, while this is great, yeah, so even if you're grabbing external stuff, because you're not reinventing the stuff, you're not an expert for PDF libraries, you're not an expert for web components. So grab this knowledge from outside. If it is open source, it's perfect because you can analyze it. So you have the source code, you can scan it, you can do all this static application security testing. So SAS and DAS is dynamic application security testing. So, and you can shift your security testing even left, because you don't need a running system to scan something. You can do it during the development time. So yeah, but you have two things you should think about. If you're using open source, you trust other people. That's not bad, but you have to check it against known vulnerabilities, against this dependency and all transitive dependencies. Because here, what we have a direct dependency, a Java dependency, but in the end, we have a dependency tree that is even crossing technology borders. We have a dependency tree on the NPM side in the JavaScript world, and then different transitive dependencies as well. So if you're just dealing with the Java side, you will never see it. So this is one thing you should be aware of. And the next thing is that is poison sometimes for your business is a right license at the wrong place inside your production line. So this can cost a lot of money or can even destroy your project. So open source is good, but you have to fight against known vulnerabilities and against compliance issues based on licensing. Oh, this right license at the right time. Okay, there are two things I want to highlight here is you hearing quite often this time to market and make or buy. So time to market is just the management level will say, we have this use case, must be as fast as possible into production and go it. So what you're doing, you're defining this use case, you're discussing a little bit, yeah, everything's fine. Then you're implementing it, you're testing it, and then you're shifting it immediately to production. You're in an agile environment, that's fine. But sometimes with security reasons, they're doing it different. So we have exactly the same. We have time to market. If there's a vulnerability and we know it and there's a patch, it must be pushed to production as fast as possible. And I see so many organizations that have for use cases that are direct influencing the money, the incomes, turnover. They have this, you define something, you have the freedom to deploy and then do it. But with security stuff, they're doing a different thing. Okay, there's a security issue. You want to change the dependency. You need an approval for this one. You have to register this one or whatever, different things. So this time to market in security issues is exactly the same. It must be as fast as possible. So try to make sure that there's no process blocking this fast deployments if you're talking about changing stuff to avoid vulnerabilities or compliance issues. Make or buy is exactly the same. We don't have the specific knowledge. We are buying a product. We are grabbing an external consultant. But here we are the same. You as a software developer, you have always make or buy this decision, because should I write this PDF library by myself or should I add a dependency? No, you should add a dependency if this fits. So you are buying. And here's exactly the same. Buy if you can't and make just what you need. Don't spend time to build or reinvent stuff. And this leads to more and more complex dependency trees. And this is good. But if you are looking at the whole tech stack, what we will see is if you're writing an application here, your source code is a big part. But even if you're counting all lines of code of all dependencies, mostly, not every time, but mostly the lines of code of your dependencies are way higher or way more. The amount of lines of code is way bigger than your own written one. Even if you're writing 100,000 lines of code, your dependency mostly are bigger. And the same with Linux, with operating system. If you have an operating system, you're not writing kernel driver mostly, so you're writing a few configurations, and the rest of the operation system is a dependency. It's a binary that you're grabbing, a bunch of binary, a composition of versions, different binaries. With Docker, it's even worse. It even starts with a from statement, with a dependency. And Kubernetes is the same. You have your Helm charts or some configuration, but you're not writing this stack by yourself. And again, what most people are forgetting, your whole tech stack for DevSecOps is a dependency, because you're grabbing your tools. You're not writing your own CI environment. You're using a CI environment. You're using a compiler. So here, looking over the whole tech stack, you will see that in the most cases, the binary, the external grabbed stuff is by far bigger than 90% compared to what you are writing by yourself. So if you want to fight against polyglot environments, or if you want to fight against vulnerabilities, it makes sense not to focus on your self-written code, because this is tiny compared to the rest. It makes sense to focus on binaries, on dependencies, on everything you're buying, not only from your tech stack that's running, even your production environment. And this means focusing on dependencies if you're fighting against whatever kind of vulnerabilities is one of the efficient ways if you start. So this is a quick win. This is it's a low-hanging fruit to start with security, because you're covering such a big place. We have two things, compliance issues and vulnerabilities. You have different efforts in beginning with this one. If you're in compliance issues, you need first some kind of lawyer or a person that's able to decide what is a good license for what step in your production line, what's a bad license. This must be defined. And then the machine can just constantly scan all binaries against this license and can say, okay, here is a transitive dependency, and this is again this compliance issue. So this license not allowed in this runtime environment or whatever. With vulnerability, it's a little bit different. You can just say to the machine, scan everything, and then you will get a report. And with this report, you start working on this one. We have slightly different behavior with compliance and vulnerabilities, compliance issues and vulnerabilities. If you have compliance issues in your whole tech stack, then it's mostly a single dot. And this single dot is must be replaced. And this is a bad thing. So if you have a stable technology dependency tree, then mostly you have no change inside a project to a different license. Well, Jakarta EE, Eclipse EE, whatever EE, even the owner change. So you have sometimes projects that are switching the license. And this is good that the machine constantly scanning it. And it could be that, for example, the developer of this library is not aware of this topic or don't care or whatever, and he's using a transitive dependency that's not fitting to your dependency tree or your license tree you have. But if you have something with a compliance issue, there's only one way to get rid of it. You have to find a semantic equal implementation. So you have to remove this one, and you have to switch in a completely new implementation that's running on a different license that is green for you or white labeled or whatever. There's one thing. Vulnerabilities are a little bit different. Vulnerabilities are in some kind of dependency. And to get rid of a dependency, mostly it's just a different version of the same thing. So if you want to fight against vulnerabilities, you're talking about a different composition of versions of the same components. If you're fighting about compliance issues, you're talking about a different component, composition of components. With vulnerability, you don't have to find semantic equal implementations, but vulnerabilities can be combined over different technology layers to different attack vectors. And this means even if you have a vulnerability in some of these technology layers with a low CVSS value, by the way, if you want to know more about CVSS, what does it mean? I have a talk on my YouTube channel called CVSS Explained, that I'm explaining all these different metrics and how they are calculated and all this stuff. And the CVSS level could be low for one thing, but in combination with other vulnerabilities, it could be a high risk for your business, so for your environment. Yeah, that's it, because now a vulnerability is not bound to one technology. Vulnerability is bound to the context, to the whole composition of all possible attack vectors of all technology layers. And this means you need the full impact graph, definitely. What's a typical lifetime of a vulnerability if you want to find against it? Someone is creating it accidentally or on purpose, doesn't matter. So the vulnerability is somewhere in the field, and it will take some time until it's found. Can we do something against this time range? Sometimes yes, sometimes no. Big companies can say, okay, if you find a vulnerability, we will pay money or whatever. But you need some researchers or some security researchers. So most of us are not really qualified to fight against unknown vulnerabilities. And they have a daily job. It's not their job to analyze this millions lines of code. But at one point, this vulnerability is found, and then we have two passes. We have the pass of a good one and a bad one. If it's a bad one, then the lifetime for us is invisible because he's using it to sell it in the darknet, using it for its own whatever task you want to do. If it is a white one, a good one, then he will provide this information somehow. If it is inside a company, it's sometimes in a way that they are creating a patch, and then in the release notes, you just see, yeah, there was a security issue and this patch is handling it. And it's not really communicated to outside. So I see this one, it's a critical pass because you don't know really what's going on. The good part is if someone is selling it to a vulnerability database with description and all that stuff, but who's getting this information, well, the economy is deciding. So who's paying better? He will sell it because they're searching for it and they want to earn income with it. So they're selling it to this vulnerability database that's just paying more. For us means until this is, or between it's found and public available, we can't really do something with this. We need it until it's consumable by us as a developer. So I need this information in the database. What database should I use? Well, whatever database you're using, you have always just a subset. What we need is a superset of it. And this is what exactly JFrog is doing. We are not deciding this is a good source or this one. We are aggregating everything we are getting from free resources, commercial resources, from partners, and merging this one in a huge vulnerability database. And this is exactly what you need. You need a superset of vulnerability databases so that you have the most part. And over the time, the amount of known vulnerabilities will be bigger than the amount of unknown vulnerabilities. But if this is consumable by you because it's provided, then the time is running, then it's time to market. You have now this need, you know what you have to do, what you have to replace, and then a good CI environment and so on is really what you need. So what is a good safety build against non-vulnerabilities and compliance issues? Well, a perfect test coverage. You need a perfect test coverage because if you have a compliance issue, you're grabbing one thing out, pushing something in, you must validate the functionality is the same. If you have a new composition of versions of the same dependencies, you have to define if everything is doing exactly the same that's done before. So a good test coverage, a strong test coverage is definitely your safety belt because the biggest weapon against non-vulnerability is very efficient dependency management. That's the highest impact. I'm a big fan of mutation testing because it's a way stronger test coverage than line coverage or branch coverage. If you want to know more about mutation testing, check out my YouTube channel. I have a talk about mutation testing there and will show you how to deal in Java with some open source tools. Okay, so next thing is if you have now the possibility to consume the vulnerability informations, the next thing is how to map it, how to do it, what is the tooling. So what we are offering is for open source and for private projects, for example, a free tier, so you have free access to this one. I can share this link or maybe in the description of this recorded talk then later. So that you need something where all binaries are going through and something that's able to scan all binaries. Because if you're grabbing binaries from different places, then the challenge is that it's very hard to build a full impact graph to get the whole impact of a vulnerability. With Artifactory from JFrog, we have, I think, 25 or 27 different package managers from NuGet, over Maven, over Debian, whatever. So you can use Artifactory as a gateway, as a proxy, as a security gateway, more or less, for your whole CI pipeline, but even for your infrastructure. If you're using Debian in your infrastructure, grab this Debian packages over Artifactory. So it makes you independent against there's refresh rates, or there's pull rates from Docker and all this stuff. And on the other side, if you have a place where you're understanding the whole package manager, and this means you not only see this is a dependency, but you're understanding this dependency will have these transitive dependencies, or this jar is in this web archive used in this Docker file, and this Docker file in this Helm chart, then you can build a full impact graph. And this is done by Xray. Xray can read all these binaries and all this metadata from Artifactory because we have it there, even with build information. Thinking about the topic that's swapping from US now with S-bombs, means that you have to map your environment or your needs. And we have a different strategy. I don't want to go into the details. You can check out my YouTube videos on how to create a policy and rule. But what you have is you can have rules, you can compose policies based on rules, and then you can map this technology independent description to different repository types. And then you have a constant scan. And we have this web UI command line interface, even with a web IDE plugin. And back to the topic with polyglot environments. So you as a software developer, you're familiar with Java, and you got this convenience library from your colleague. He has done a great job, perfectly. But now you have dependencies not only to Maven, you have now dependencies to NPM as well. So you must make sure that you understand that you are collecting everything over one entry, so that you're really grabbing not only Java over one Artifactory, and this one is grabbing from the outside world. And the next thing is you need something that's immediately giving you the full understanding of this dependency tree. And what's a good place for this? Your IDE. Your IDE is a perfect place to start, because if you're coding the whole day or a few hours and then pushing to the CI environment, then the CI environment would say to you, oh, you have a compliance issue. Oh, there's a vulnerability. You lost a lot of time. And this is just losing a lot of money. But it would be perfect if you're inside your IDE and you're just adding a dependency, for example, this dependency from your colleague to your POM. And then you see immediately, oh, this dependency is grabbing this NPM package as well, and there is a vulnerability. And then you're defining your first definition dependency, and you see already if there is a vulnerability or a compliance issue. And this is exactly done with a free available IDE plugin that you can connect to Xray. There's a how to connect it. It's a few clicks and then it's done. But with this, we are shifting again this environment with a full impact graph. So against all these polyglot tag layers, even inside your IDE, before anything is running. So you don't need a prototype that's running to scan it. You don't need to create a Docker file to scan it. No, you're adding as a dependency and you see what's going on in your tech stack. And this is really saving a lot of time and a lot of money. Okay, Xray can do a lot of other stuff. So we can start webhooks. We have REST interface. You can build active workflows, dynamic workflows, all this stuff. If you want to know more about the possibilities, join my webinars at JFrog. They are really talking about the product and the product features. I don't want to highlight too much here about this one, but then I will show you how it looks, how it operates, or come to my workshop. I will show you how you can work against vulnerabilities then with this tool stack. Okay, so checking the time, I think slowly, I have to come to the end so that we can have a Q&A. You can try it. I can really recommend to use this bit.ly link. Then you will get access to the free tier on cloud. You can have it in Google, Amazon, Azure. Yeah, I think, or if you want, you can do it on-prem. So it's not only cloud, it's on-prem or even hybrid. So if you need balanced architectures, I'll say. If you want to see what's coming through this now to do this, check out my YouTube channel. Then you can check this video. I don't want to show it here right now to you. It's up to you to decide if you want to try it and then do it. Okay, so what we learned so far, just as a summary. We learned that we have a bunch of different technologies. Even if you're an old and experienced developer in one technology means if I'm starting with the next one, I'm a junior again. I'm doing all of this mistakes and all these crap, I'm doing again. I have to learn. I have to analyze a compiler, a runtime environment, and so on. But even if I'm not talking about a distributed system organized by Helm charts or whatever, even inside my application, I have for every tech layer corresponding dependencies, technologies, life cycles of this technology. And I have to fight against known vulnerabilities and compliance issues because both is poison for my business. So it must be in your hands that you can decide as fast as possible if this is something that you should work on. At least you need the information so that you are able to decide. So all of these tech layers means that you're grabbing mostly 99% of your project via dependency from outside, and you need the full impact graph to analyze what is really going on your tech layer. You have different possibilities to try it. First of all, you need a single logical point, like Artifactory, a repository manager, so that all binaries are going through this logical point. You need a scanner that's understanding all these different technologies to give you a coherent report of all tech layers independent from the technology. If you want to try it the free tier, and then you can just start with this. It has pipelines as a CI environment, Xray for security scanning, and Artifactory as a repository manager. Well, otherwise, if you want to know more about this stuff, check out my YouTube channel. I really would like to see you as my new subscriber. I really would appreciate it because since the pandemic, I'm not traveling to conferences. I'm going to the woods and recording them and stuff. So if you like it, go there, subscribe, turn on the bell would be perfect. And otherwise, connect via LinkedIn, Twitter, if you have any questions. Otherwise, I hope you have a bunch of questions now in the chat so that we can have a Q&A. And with this, let's start with Q&A. Huh?
The bad news is that we don't have questions so far.
Then it was too much.
We have one, which is if the recording of this particular talk will be on YouTube. Yes, it will. If you come back in 1 or 2 weeks' time, all the videos will be on YouTube.
Yeah.
So does any of you have a question for Sven?
Well, don't be shy. Otherwise, there are several questions I'm hearing quite often say something like, okay, security sounds like black magic or whatever. Is this difficult? Well, no, if you're not starting analyzing lines of code against possible anti-patterns with, I don't know, machine learning, whatever, it's not black magic. It's just knowledge from others, and the tooling can help you. So focus really on the dependency. If you start working against non-vulnerabilities, do it as early as possible. And sometimes people are asking me, oh, I have a different tool stack. Now I have to deal with security. Will this slow me down? If you're doing it wrong, yes, will slow you down. It's the same with quality. But if everybody in your team is working on one part of the security, for example, the Maven people are working in the Maven stacks, the other people in some other stacks, but you have a general overview to analyze in the whole team from dev to ops, then security is something that you're just doing on the fly. And this is something that reminds me very to performance. You had this development phase and then this performance team that's just destroying everything to tweak it. And then you get this bunch of code back and you say, okay, next release, how to implement a new feature with this optimized piece of code. So what was the best thing? First of all, better algorithms, beating technology tweaking. On the other side, if you start against performance bottlenecks in the beginning and everybody's doing a little step, then it's not a big issue anymore. And the same with security. So don't be afraid. Start as early as possible. Don't be shy. Try it. Trying is better than doing nothing. And see what the best tool stack for you. Huh?
And a lot of this is automated, right? So it can take up some of your time the first time you do it, but then it's automated. So yeah, the impact is a lot less.
Yeah, you need a strong CI environment that's just doing the boring work. but don't push everything in the CI. So some stuff could be done earlier, because otherwise you're wasting your productive time. Yeah. So this is a trade-off, but mostly the whole automation potential must be grabbed. So how to make a release, how to push it to production, how to give it free, make sure that there is no process blocker like, oh, I need agreement from this person or that person, and he's just, I don't know, sleeping for the next 5 hours. So, and if you have this autonomy and you have the power to decide and to do, then you have the strongest weapons already in your tool set. And then you need supporting tools, because you can't check all dependencies against license issues. It's impossible. It's just too much. Or against, so even extracting the whole dependency tree of regular web is sometimes a huge tree. Yeah, that's more or less everything. So now it's up to you to try it. So that's a good thing. Just try it.
Okay, so we don't have any questions, but we have attendees saying thank you, Sven. So thank you, Sven.
Yeah, welcome.
Thank you again for joining us. Hope to see you in the near future again.
Yeah,
Bye.
would be perfect. Just let
Thank
me
you
know.
very much. Yeah.
Okay.
We'll be in touch. Thank you very much.
Okay.